Hello everyone and welcome back to this What's New series. In this video we're going to look at what's new in SOLIDWORKS flow simulation. In this model I have a transient analysis of a cylinder already run, and we are currently looking at a time instance of time equals 30 seconds, and here is a cut plot that you see. Now in previous versions you had to go in and do the animation feature to look at how it changes as a function of time. With 2017 you now have this transient explorer option. It does take a few minutes to load. I had paused the video there for about 20-30 seconds, but you see that it pulls up this little bar right here that now lets you look at the animation of the changes in the result for the same cut plot as a function of time. This helps you more easily analyze the results of a transient analysis using SOLIDWORKS 2017. Let's quickly switch to another model. In this case, we have a heat exchanger, and here is the flow trajectory results. Real quick, you can see that there is an inlet and you have an outlet, and there are these three different angles that, based on the variation of them, would determine what the flow rate is in each of the three different chambers. Until SOLIDWORKS 2016, you had the option to optimize the study with respect to one parameter. 2017 lets you do multi-parameter optimization, where SOLIDWORKS uses the concepts of design of experiments to go ahead and look at multiple variables changing with constraints such that you reach an optimal goal. So in this case, we wanted the flow rate to be as similar as possible. So that angle was given a range between 0 and 60 degrees, such that the mass flow rate of all three of them had the least difference. Looking at some of the results, it went through and looked at a few different iterations, about 31 different iterations in this case, before it found an optimal point where the mass flow rate is as close to each other as possible, given a small level of discrepancy. The multi-parameter optimization is a huge improvement because now SOLIDWORKS flow simulation lets you automatically improve multiple design parameters and compute the results that are essential to you without much user input, hence letting you focus more on the design of the system itself as compared to altering these different parameters. The last example that we're going to look at is this electronics cooling model. As you can see, this is a well-defined study with a lot of goals and different options. In any general numerical analysis like CFD and FEA, it is often recommended to start small and then go bigger and make your analysis more and more complex. In this case, we have a few studies already defined. I'm going to go ahead and open up this component in the bottom, and you're going to see that this component already has an external analysis defined with the printed circuit board definition. Now, since we already have the result on a lower level component, with SOLIDWORKS 2017, having done a flow simulation study on a lower level component, you now have the option of automatically inputting those result files into a higher level assembly component. I'm going to go to the customize tree option, and you see the new from components option. This adds a new line item on the tree, and you can use this add from components option to add the results of all the previous studies. I'm going to go to a study that's already been defined. As you can see, a lot of the material definition and additional data input has been defined from the lower components. And then once the study is ran, I can go ahead and load up the results and look at some of the important outputs that pertain to me in this case. Here is a surface plot for the temperature definition. We can go ahead and select a flow trajectory plot. I'm going to select the top plane and look at the temperature distribution. And here we can see how the temperature changes and how the fluid flows as you go across the different regions. These are some of the enhancements with SOLIDWORKS 2017 to improve your everyday workflow and make it a little bit easier for you to analyze your designs inside of SOLIDWORKS. I hope you've enjoyed this video. Thank you.